Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from Probability and Statistics 1. And this two particular question belongs to paper 9709/55 for the session May June 25. The first question 2, which is the heights of trees in a certain forest are classified as tall, medium or small. The heights can be modeled by a normal distribution with mean 20 meter and standard deviation 5 meter. Trees with a height of less than 14 meter are classified as small. For 150 randomly chosen trees from this forest, how many would you expect to be classified as small? So in the first question, it is expectation, and we know expected value means actually mean. So we will have to find mean, and mean is the product of n and p. That means total number of trees into probability. So let us find the probability. Then let us write x belongs to normal distribution. Okay, it is already written that normally distributed. Then for normal distribution, the parameters are what? Mu and variance. Mu is mean. Mean and variance. Mean is 20 and variance is the square of standard deviation, that is 5 square. So these are the two parameters for normal distribution. One is the mean value and the other one is the variance. Well, now we are going to find the probability. So probability of what? X is less than 14 meter. Okay, so x is less than 14 meter. X is less than 14 meter. Okay, so after that, we will have to standardize this score. Z less than 14 minus mu is 20 over standard deviation, standard deviation is 5, already given in the book. Then if we subtract this, it must be negative. Z is less than negative, it is going to be 6. If 6 is divided by 5, it is definitely 1.2. 1.2. Well, now through a graph, we will see what is the condition of the probability. So this is our normal graph. Okay, in this normal graph, if we look, normal graph is always symmetrical. Suppose this is 0 and our standard deviation is negative 1.2. Let me rewrite this, negative 1.2. That means z is less than 1.2. That means this is left part, less than 1.2. So this portion is our probability to be obtained. Okay, so for this, actually none of the probability to the negative corresponding z score is given in the normal distribution table. That's why what we will do, so we know that this portion is our requirement. Okay, negative 1.2, and as the normal distribution graph is always symmetrical, so this portion here it will be 1.2, and our necessity of probability is this region. Okay, so for this region, definitely this region and this region will be exactly same, because normal distribution curve is symmetrical. Well, now the question is, how can we find this one? What we will do is, we will find the probability of the left part, all of this from whole probability means 1. From 1, if we subtract this left part, I mean blue shaded part, shaded in blue, the left part from whole probability. If we subtract this left part, we will surely get the right tiny red part. I mean blue part. If blue part is subtracted from whole of the probability, we will find this red part, and definitely this tiny red part is exactly as same as this part. Okay, so this part and this part are exactly same. So what did we do here? We have just shifted the negative z score to the positive z score. That means right side of 0, mean value. Here it is mean value, and we know that the normal distribution graph is symmetrical. Well, so for this, what we can do, we are going to write here probability of probability of z less than negative 1 is from 1 whole probability. Total probability is always 1 from 1 if we subtract the left part. So for left part we will write z less than 1.2 instead of negative 1.2. I think you got my point that 1.2 is positive now, because there is no probability given in the probability distribution which is applicable for any negative z score. So it's all about positive z score, and probability is always more than half, so we will have to choose this. Then we are going to write 1 minus when probability of z is less than 1. Let's find the corresponding probability. For that I will have to collect this image is our requirement. Yes, over here, not over here, on the other page. Let us find over here. No, not there also. Let us take a new page. Okay, then in the new page, on the new page we will, okay, this is our new page. Then we are going to find our normal distribution table. Okay, so normal. So from this one, what we will do, we will find our z score. Our z score was 1.2. Let's see where 1.2 is given. Means 1.20. Okay, let me mark with red ink. So 1.2, I can show you here. 1.2 is over here. Look, 1.2 and 0. Okay, this one. So row is 1.2, column is 0. That means directly this is our probability. So our probability is 0.8849. I think you have got my point. Our z score was 1.20, and you can see here nowhere it is written that negative z score. So this probability distribution table is always given for positive z score. That's why we have found we have converted the negative z score, shifting it to the right side. Okay, so a 0.8849, 0.8849, point. Let me change the color of the ink. 0.8849. Then if we subtract 0.8849 from 1, it is going to be 1 5, then again 1 1 point. Okay, so it is 0.11 5, then 1 1, 1 and 1. So 0.1151 is our probability. We didn't forget that the question has told us to find not probability. Look at this, is expected value. We are supposed to find expected value. So ex is equal to, we know, I can write over here Ex means actually mean value. How can expected value means actually mean? How can we find mean? Mean value is total number into probability. Ex is equal to, no, let me write just beside this. Okay. So our total number of trees is how much? 150 randomly chosen trees. So 150, and our probability for each tree is 0.1151, 0.1151, 0.1151. Then finally, if we multiply this, it is going to be 17.265, 17.265. Now they have told us to find number of trees. Number of trees cannot be actually in fractional. So there are two possibilities. If we round it up to three significant figures, it is going to be actually 17 trees. But in another way, if we consider that, look at this, more than 17 trees. It means more than 17 trees. It's actually 18 trees. So 18 trees is the probability. We will have to write it in trees cannot be fractional. Remember, number of trees is always in whole number integer. So if we convert 17.265, you can write either 17 trees or 18 trees. According to me, actually it means the mean value is more than 17. So more than 17 means it will be 18 trees. Well, let's move on to the immediate next question. The immediate next question says, trees of this forest are classified as tall if their height is at least h meter. 25% of the trees are classified as tall. Find the value of h. So, following the previous solution, we can solve it easily because we are still under the same normal distribution. So, for normal distribution, we know x belongs to normal distribution and the parameters are what? Parameters were mean was 20 and our variance was 5 square, means standard deviation was 5. Now they have told that probability of x is, look at this, at least, that means their height is at least h meter. Okay, so at least, what does it means? It will be either more than or equal to h meter, and the probability is given 25%, means 0.25. I think you have understood as I have written here. They have told height will be at least h meter, so it may be greater than h meter or equal to h meter. Now we are going to standardize as we did in the previous case. It is going to be probability of z score. Z is greater than. Now here you may ask a question. Instead of greater than an equal symbol, actually normal distribution graph is always continuous. So for continuous value more than h or equal to h, this is right side. So it's all the same actually. Then h minus our mean value is 20, then it is 5. Right side is 0.25. So please don't get confused with this equal symbol. It's greater than or equal to is actually means same in case of normal distribution, because this is applicable for continuous random variable. Now we will have to find the corresponding z score when the probability is 0.25. Now look at this. This is our graph. Okay, in the normal graph, yes, our probability is 0.25. From left side, if we start, 0.25 is very meager, because here this is zero point 0.5, half of the whole graph. So 0.25 may fall over here. Look at this. This is our probability because it's very tiny. Okay, 0.25, and here z score is what, h minus, here let me write here 0.25 with different ink. This is 0.25, that is 1/4 of the whole graph. Now this curve is definitely similar to this portion. Look at this red shaded region and blue shaded region must be equal because the graph is symmetrical. Now what will it be, as it is our z score is, look at this, original probability is lying on the left side. Okay, so z score is here, it must be h minus h minus 20 over 5. So this point of z score is this. Okay, and here it is going to be h minus, it must be negative. Okay, so we will have to write negative. Sorry, I made a little mistake, it is not less than, it is actually greater than. So not the left part, it will be right part. Let me draw once again. Our probability is lying right side of the z score, so it is 0.25. So 0.25 is this portion, not this portion at all, it is over here. So this tiny part is actually 0.25. Okay, now what we can do, that means where is our z score lying, our z score is lying over here, h minus h minus 20 over 5. Okay, this is our z score. So this portion is our probability, but we know that in probability distribution table none of the probability is less than zero point 0.5, all the probabilities given is more than zero point 0.5. That means this portion. So what we will do, we will find this one. If this is 0.25, this is 0.25. Okay, this portion is 0.25. Let me write once again, this portion is 0.25 to 5. So what will be the left part? Surely this black inked, I mean black shaded part, dark part must be 0.75. I think you got my point. Look, we are not making any change to our z score. Z score is as it was. So this black part, dark part is our probability. As for 0.25, we cannot find any z score because all the probabilities in the normal distribution table is more than zero point 0.5, and this portion is actually 0.75. So we can easily find the probability of 0.75 when the corresponding z score is h minus 20 over 5 and it is lying on the right side, so it's definitely positive. Okay, so let us find the probability of 0.75. Once again, I am clarifying, we cannot find for 0.25 because none of the probabilities given in the probability distribution table is less than zero point 0.5. So let me show you from the graph. Yes, over here. From the same graph, if we see here, let me erase this after zooming it out. Okay. Look, none of the probability, the first probability started with what? 0.5. Look, so all the probabilities are more than 0.5. That's why we have chosen more than 0.5. I mean, alternated way. Instead of 0.25, we have found the probability of 0.275. Okay, now let's see what is the correspond. We require actually probability, not z score. So for z score, we will have to take one more Worksheet, let me see, does it have the lower part? Lower part is not clear over here. I am going to show you from the next image. It is normal distribution, first one. Yes. Not on this page. On the next page. Yes, over here. Over here, if we, yes, this is the lower part of the same table. Our probability is 0.75. Look at this at the bottom of the page table. When probability is 0.75, our z-score, corresponding z-score is what? This is our probability 0.75, and corresponding z-score is 0.674. So we are going to write 0.674. We are not searching for probability. Already we do have probability. That's why we are going to get the z-score. So our z-score is 0.674, and I have already shown why have we taken 0.75 instead of 0.25, because none of the values is 0.5 in the probability distribution table. So 0.674, let us write 0.674. Okay, so our z-score is 0.674 when probability is 0.25. Now please don't get confused. As I have told, it is going to be 0.75, because point z-score doesn't get changed. Whether it is 0.25 or 0.75, our z-score is same. That's why probability will not be different. According to z-score, its greater part is 0.25. Well, so look at this here. We can write hence h minus 20 over 5 is equal to same. This one is z-score. Look at this one is our z-score. Okay, and hence this one is also our z-score. So they must be equal to each other, because for the same probability z-score must be equal. So 0.675. No, I will have to change the ink. 0.675. After that, what we will do is h is equal to h, or h is equal to by 5. If we multiply, it is going to be 5 into 0.675, and if we transpose 20 to the other side, it is going to be plus 20. Hence our h is equal to, hence our h is equal to 5 into, let me use my calculator, 5 into 0.675, 3000, 375 plus 2, so it is 23.37. 23.37. So if we round it up to 3 significant figures, it is going to be 4. So that is what our value of h is. I think you have understood this. And from the solution number 2, you have learnt that for any probability which is less than 0.5, we will find for the alternated one. Always the probability given in the normal distribution table is more than 0.5. That's why always z-score remains same, because z-score just shows the left side or right side. Okay, so as if we require left side small part, always we will find the probability which is greater than 0.5, and corresponding z-score must remain same. Then let's move on to question number 3. Question number 3 says Yes, it is 3. In a certain large school, on average, 2 pupils in 5 have music lessons. A random sample of 80 pupils from this school is chosen. Use an approximation to find the probability that fewer than 27 pupils have music lessons. Okay, so still we are under another normal distribution. So let us write that normal distribution x belongs to, not with this ink, x belongs to normal distribution, and the mean value is what? Look at this, we will have to find approximation. For approximation, always it means, sorry, it is not a normal distribution given. Actually, we'll have to turn it into normal distribution. Look, approximation is the clue word over here. Whenever the word approximation mentioned, it means the distribution is given in binomial distribution, which is to be converted to normal distribution. So for binomial, we know the parameters are x belongs to binomial, and we know the parameters of a binomial distribution is n and p. N is 80 and probability is what? 2 peoples in 5. So 2 over 5, 2 over 5 means how much? 0.4. Okay, then if p is zero point 0.4, our p is equal to 0.4, then q is going to be 0.6. Okay, q is going to be 0.6. 0.6. So our probability of having music lesson is 0.4. The probability of having no music lesson is 0.6. So it is going to be 0.4. Probability is 0.4. Then for approximation, what will we do? We will just convert this binomial distribution into normal distribution. So x belongs to normal distribution, and you know, for normal distribution the parameters are mean as well as variance. Mean is n into p. If we multiply n and p, it is going to be 32, and our variance is npq. So 32 into 6, I mean it is going to be 19.2. 192, that means 19.2 is our variance. Well, then they have told us to find the probability of x less than, look at this, what is this? To find fewer than 27 pupils. Okay, so we will write less than 27, but remember we are converting a binomial distribution into normal distribution. Binomial distribution is always applicable for discrete random variable, whereas normal distribution is applicable for continuous random variable. So we will have to do continuity correction. If 26 is uh, corrected with continuity, it is going to be, it is less than, so less than 27 means it is going to be 26.5. okay, remember, don't get deviated from this point. Whenever you convert a binomial distribution into normal distribution, you must not forget, let me write here another n, you must not forget to do continuity correction. Okay, well, now we will standardize the score as we did in the solution to question number 2. Then x z is less than 26.5 minus mean value. How much is our mean? Our mean is 32. 32 over standard deviation. Standard deviation is always square root of the variance. Square root of variance. Then probability of z less than, look at this, as we are subtracting smaller numbers, so definitely it is going to be negative. So z less than negative. Okay, it is going to 5.5 over 19.2. 5.5 over 19.2 is 1.255. 1.255 is our negative z-score. Well, so how will our curve look like? Well, our curve will look like this is 0. As our z-score is negative, so it must lie on the left side. Okay, it is over here, 1 point negative 1.2. So less than negative 1.255, which part is our probability? This region, red shaded part is our probability. Okay, these probabilities to be obtained. So for this, how can we find this portion? We will look at this. This is the another part. Okay, this another part. From whole probability, if we subtract this right side, okay, though right side cannot be subtracted, we will find the probability if we subtract the larger part. Okay, let me show through another graph. It will be easy to understand. Okay, I'm drawing one more graph which is exactly like this. So suppose this is the another graph. So we require the red shaded part. Okay, so red shaded part can be over here also. Look at this portion, because you know the normal distribution graph is always symmetrical. So red portion we have shifted to the right side, and black shaded part is this part. Okay, so what will we do? We will from whole of the probability will just subtract this, and our z-score will be shifted now on the right side. And look at this, all the z-score lying on the right side of 0 mean value or mean line, it must be positive. So here 1.2 is our z-score. It's no more negative, because the probability distribution table provides the probability of corresponding positive z-score. There is no negative z-score in the probability distribution table, but it's all the same. As I have told, it is actually this red shaded part and this red shaded part in both the figure is exactly same. But as for negative corresponding z-score, there is no probability is given. We will try to find the positive z-score, and hence it is going to be from whole of the probability. Look, whole probability is 1. From 1, if we subtract probability of z less than 1.255, it will be exactly same, because the shaded part is same, as you can see. Now let's see the z score, I mean probability, corresponding probability when z score is 1.255. From the graph I can show you. Let me go to a new page. Yes, here. Then we will find our normal distribution table. Yes, not from this, from the whole, the larger one actually. Yes, this larger one. So from here, let me zoom it out. Let me. Well, our z score is 1.255. So let us say this is 1.2, and then 5 is over here, and row is this. That means this is our probability. Okay, then another 5, 1.25, then another 5 is over here. This is 5, and our column is this. No, not this one, the third one. Okay, so 1.8944, if we add up this 9, it is going to be 53.8953 is our corresponding probability. And let us right over here. So our corresponding probability when our z-score is 1.255 is 0.8953. 0.8953. After subtraction, we are going to get, if we subtract this, it is going to be 0.1047. This is what our approximated value. So what have we learned from here? We have learned two parts. One is whenever approximation word is mentioned, then we will have to convert the binomial distribution into normal distribution. Okay, and in normal distribution, if our z-score is negative, we will shift it to the right side when it will be positive. For that, if we require tiny part as probability, suppose this part, if we require the tiny part, I mean this part, these two parts are exactly same, just for this tiny part always we will subtract the greater part from one whole of the probability. That's what we did here. We have subtracted the left part, I mean greater part, from whole of the probability, then we got this corresponding probability. Let's move on to the immediate next question. Question number B says a random sample of 10 pupils from this school is now chosen. Find the probability that no more than 2 pupils have music lessons. Okay, so this is, look at this, this is simply a binomial distribution. So we will write x belongs to binomial distribution, and for binomial distribution the parameters are n and p. Number of total pupils is 10 and probability of having music lesson we reused it as zero point 0.4. Okay, now they have told us to find the probability of x less than no more than two people. That means maximum there is to be either less than or equal to two people. That means we'll have to find when probability there is no x equal to 0. That means there is no music lesson. Then, sorry, there is music lesson if there is no people. Then if there is only one people who has music lesson, or if it is when only there are two people, no more than two people. So either there may be no person or no student has music lesson, or only one student has music lesson, or two students have music lesson. These are the possible cases for this probability. So when probability is 0, x is 0, that means none of the people has chosen music class. So that means all 10 people chose for non-music class. So the probability is total is 10, 10 choose 0, none of this. So probability is zero point 0.4, none of this. Okay, none of this, all 10 has chosen, that means q raised to 10, because all 10 are out of music class. Okay, when there is only one, so out of 10 there is only one student who chose music class is zero point 0.4 probability, only one. Then rest of the nine student didn't choose music class. After that, let me zoom it in. After that, there may be only two students out of 10, two has chosen music class. So for music class probability is 6. Rest 8 student didn't choose music class, so for them probability is 0.6 raised to 8 8. Let us do this calculation here. From 10, if we choose no one, only there is one way to choose one. So and zero point 0.4 raised to 0 is also 1, so it's actually 0.6 raised to 10. Plus, from 10 student, if we choose only one student, how many times we can choose? 10 times. 10 using calculator you can do this, but manually I can explain that 10 choose 1 means actually 10. Okay, because if you choose 1 out of 10, how many ways you can choose? How many times? 10 times. Okay, 10 into zero point 0.4 into zero point 0.6 raised to 9, zero point 0.6 raised to 9 plus 10 factorial, 10 into 9 into 8 factorial over 2 into 8 factorial. If you expand this, you can write in this way. And zero point 0.4 two times. So two students choose music class. So it is 0.4 two times, 0.4 two times, and 0.6 8 students. 0.6 8 student. Now if we calculate this, what is it going to be? 8 factorial can dissolve each other, and 2 can dissolve this 10. It is going to be 5. Okay, so finally it is going to be, let me use my calculator, zero point 0.6 raised to 0.6 raised to 0.6 raised to, okay, it is 0.6 raised to 10, zero point 0.6 it is going to be 0.16 and 7 is the probability that maximum 2 student who chose music class. So that's all about the solution to both of the questions, question number 2 as well as, let me show question number 2. Question number 2 is on this page. 2a as well as b, both of them belong to normal distribution, and I try to explain every tiny part so that you can understand it easily. And then our question number 3 is over here, which is simpler actually than the solution to question number 2. So it is in 3. First one was normal distribution, whereas the final one was binomial, simple binomial distribution. So let us take leave, and thank you all for watching the video. May Allah bless us all with beneficial knowledge.